Okay, so section 1.5, absolute values and inequalities. So first of all, what's an absolute value? So if I said the absolute value of -3, hopefully some of you know the answer to that is 3. But what about the absolute value of +3? Still 3, right. So why is that? So the absolute value is actually the distance from the origin, or the distance on a number line or a ruler from 0. Okay, so the absolute value is the distance from 0. So if we had a number line, then if you want the absolute value of 3, then it's the distance from 3 to 0, which is 1, 2, 3. So the absolute value of 3 is 3, because it's a distance of 3. Same with -3 is the distance of 3. Okay, so that's what it is. So my question is, we're going to do just straight absolute values, but we are going to mix absolute values and inequalities in the same equation, and that's what you see in calculus a lot. So for example, I'm going to put 18 here. Is anyone 18 in the room? Okay, a few of you. So that's your age. Okay, so what does this mean? Now, it doesn't really apply to age, but I'll show you an example later that does, because we're going to apply to age. What does this mean? So this is saying the distance is less than 18. So what numbers are included in this as answers? How about the number 0? Yeah. What about the number 5? Yeah. What about -5? Yes. -5 is less than, absolute value -5 is less than 18. So -5 is included. It doesn't mean it positive numbers only. So what is this the same as saying on a number line? So if I were to draw a number line, and here's 18, here's 0, and here's -18. Put one on either side of this. Okay, and then we've got all these in between. I just didn't write them in. What's included in this statement? Everything lower than positive 18. So 17, 16, 15, 14, 13, all the way down to 0. And how about the other direction? Yeah, I keep going until I get to what number? -17. Not -18. How come? Because I didn't put an equal sign here. I just said less than, not equal, right? So you'd actually put this. And in calculus, we're always talking about real numbers. It's not going to say, I know when you did this stuff in school, there were sometimes integers, sometimes whole numbers, it's always real numbers here. So we would actually say that everything in between, not just those numbers, but also 17.5, 17.9, 17.99, everything. You don't have to fall right on one of those numbers, but everything in between is included. Now, how do you write that, the numbers between -18 and 18 as an inequality without an absolute value? How do you show that? So, these are all the x values between -18 and 18. So the way that you show that is that you say that x is in between 18 and -18. And you actually don't read this from left to right in a normal reading way. You read it from the middle. If you were to read this to me, you would have to say x is between -18 and 18, not including the endpoints, or if you, right? But that's how you would actually say that, is x is between -18 and 18. You don't say -18 less than x less than 18. That, you don't read it that way. So this is, the symbol for x is in between two numbers. So how do you think with an absolute value that I could show the other way, like bigger than 18 and less than negative 18, like these outsides? What do you think I could write? What if I said bigger than 18? Okay, so here's our numbers. Here's negative 18, 0, 18. So this is saying that the absolute value of x is greater than 18. So is 19 work? Yeah, is 19 bigger than 18? Yes. What about negative 19? Yes, why? Because that's an absolute value, so it's making it positive. If you put a negative 19 in there, that's saying 19 is bigger than 18, which is true. So what ends up happening is all of the numbers here work, all of the numbers on this side work, not the 18s themselves. Again, I didn't put an equal sign there, or we would color that in. And how would we write that as an inequality without the absolute value? So first of all, it's really, really important that you see that there's two separate pieces and they don't overlap, and you have to lift up your pencil to shade both of them. Right? They don't touch each other. They're separate. Okay? So first of all, you notice that. So you have to write the equations separate. You can't write equations together if they don't aren't one piece. This is one piece between, so you write the answer as one piece. When they're on either side, the answer is actually two separate equations. We'd say x is less than negative 18, or x is greater than positive 18. Or is important. You can actually put a comma. In math, a comma means or, so that's easy to remember. But when it's an and, you need to put and. So why is it not and? If we put an and here, that would be saying that x has to be less than 18 and bigger than 18 at the same time. And is there any numbers in that are less than 18 and bigger than 18 at the same, less than negative 18 and bigger than positive 18? No. So you can't put and, it has to be or. Your answers could be here, or any number over here, or any number over here. Right? And this one, you could say, you can write as an and if you wanted to, but we would write that as one piece because it is one piece. Okay, so that's sort of like an introduction, how to put absolute values and inequalities together. You see this kind of thing a lot in calculus because it's shorter than writing out the two pieces. But it is what it means. Okay, same here, not that much shorter, but it's a shorthand way to write in between two numbers when you say it's less than, and when you say it's greater than, it's on the outside of two numbers, okay? Both positive and negative. Okay, so let's go back to just plain absolute value. So what we're going to do with absolute value is solve equations. So solve for x, or any letter. I just usually put an x in. So if we have the absolute value of x is equal to 6, what are the possible answers? That's a hint. There's two. You can plug a 6 in and get 6 as the distance, and you can put a negative 6 and get a 6. So there's two answers. Not always, but usually there's two answers for an absolute value. So the solution here, there's no work involved. X is plus or minus 6. You can write it like that, or you could say x equals 6 or minus 6. You can write it with a comma, or you could put an or in between. Okay, that would be the plus and minus like this. That implies two answers. Okay, so that's the first one. What about this one? No solution. Why not?
Because you can't have a negative value.
Right, we can't put in a number and get a negative distance. The distance is measured like with a ruler. We can't get a negative. And if you put plus or minus 2, you'd be wrong. It's just no answer, no solution, nothing to do. You just say, oh, an absolute value can't be negative, so no solution. And that would be it. Now, what about 0? 0, just 0. Not 2 answers, not no answer, but 1 answer, and if we plugged in 0, it would work. So, there could be 1 answer, no answers, or 2 answers for these. Now, of course, they get more complicated. We can put something like this. Now, I'm purposely doing this one. I want you to do it in your head, not writing something down. Then I'll show you the way that we would write it down. So, what are the answers to this? Answers. What's one obvious answer? 1. You can put a 1 in there and get 4. Right? How do you have to think about the other answer? Because what else could you put in that absolute value bracket to get an answer of 4? -4, right? It can be either a 4 inside, or it could be a -4 inside, and they would both be equal to 4. Does that make sense? So that's how you think about your answer, is you say, okay, well, the inside must equal 4, or the inside must equal -4. Does that make sense? This is not dropping the absolute value and making, like, don't make up a rule that says we're dropping the brackets and you put 1 as plus and 1 as minus, because that's going to fail you when things get complicated. What you're doing is you're saying, okay, the inside of this, for this to be true, the inside is either +4 or -4, and that's how you set up the 2 equations. Okay, so then we solve these. X equals 4 minus 3 is 1. That's the one that was obvious. And then here, x is -4 minus 3 is -7. And doesn't that make sense if we put a -7 in here? -7 plus 3 is -4. So the answer would be 4. And we would say or, not and. X can be 1 or it can be -4. Or -7, sorry. It can be 1 or -7, not both at the same time, but one or the other, and they'll both work. Okay, number 5. So same idea, but not as obvious. You might not be able to look at it and know what the answer is right off, but you do the same thing. You say, okay, well, that inside could equal 3, or that inside could equal -3, and both of those answers would end up working. Okay, because whatever x makes this work, that will give a 3 inside, and whatever x makes this statement work will give a -3 inside. So 2x equals 3 minus 4. So -1/2. When we plug that in, we would get a +3. And -7/2, when we plug that in, we would get a -3. You can always check your answer by plugging them in and make sure you get 3 and -3. But usually people don't make a mistake in these unless you add 2 numbers wrong. So here's our solutions. And of course they get more complicated. But not too bad. Everything we did before leads back to this. It's just an extra step in the beginning. So this one's going to be a fraction. But before we can solve the fraction, you don't just drop the brackets. It's nothing like that. You say, okay, the inside would have to equal either 6 or -6, and you set up 2 separate questions now and solve both of them. And you get different answers. So with absolute value, it's sort of adding one more step. We say the inside is 6, or the inside is -6, and then we solve each of these separate using the methods we just learned in the last section. You solve them separate, you get 2 separate answers. So how do we solve these? What's our first step? Cross multiply? 4 times 6, 24. So there's our first one. And our second one, minus 6 times 4, minus 24. And we get 2 answers and leave them as fractions, like that. You don't want to put them as mixed numbers. When you're checking your answer, mixed numbers aren't going to really help you. So what about this one? Yeah, this will have one answer because we say, well, the inside would have to equal 0. You don't say plus 0 and minus 0, it's just 0. So the inside will equal 0, so that will give me 1. If you plug 1 in, you'll have 5 minus 5, which is 0. And this one? You have to be careful because you don't want to say the inside equals minus 1 or positive 1 because there's no solution. You can't have a negative, so you have to catch that. You have to remember, you can't just say, oh, every time I take the inside and let it be plus or minus whatever is outside, because that's not the rule. It's that this is a distance, and we can't have a distance of negative 1, so you would just write no solution. But you have to catch that. It's on the final exam, worth 1 mark. You wrote that down, right? Because you will forget that I said that in December. Okay, so that's absolute value. That's really all you do. You have to set up the 2 cases. But what we really want to do is put them together with inequalities. So let's look at inequalities just by itself. Okay? So inequalities. So we know what these are, and we could draw those on a number line. So wherever you're on a number line, if we need the number 2, center your number line at 2, not at 0, because if you have the number 100, you're not even going to see a 0 on there. You're just going to see the 100 and what's on either side of it. So you can do a number bigger and a number smaller if you wanted to, or a couple numbers, it doesn't matter. But if you're at a 2, you want to center your number line on 2. This one is not equal, so you would put a circle at 2, and then it's greater, so it goes to the right, because 3 is greater, so then you would shade, just make the line a little thicker, and an arrow on the end, and that would show it, okay? And same thing here, this one is less, goes that way. And then what's the difference here? Right, you just color that in, and greater. Okay, so this is your inequality notation, but there's also set notation. So what does that look like, the equivalent for these? So set notation, this is saying it starts at 2 and it goes all the way to positive infinity. So I don't personally use set notation because I don't like the round brackets. They look like you want to plot a point on a graph, and it's not really what it means. The round bracket here actually means that the 2 is not included, and infinity is not included, because infinity is not a number, it can never be included. Because it's an idea, and you can always get one bigger. You can always add 1 to infinity and have a bigger infinity. So it doesn't actually, you don't actually ever reach it, so you can never equal infinity. Here, this starts at negative infinity, and you can't equal that either, and it goes to positive 2, round bracket, because it's not included. So you want to write down the round bracket means not included. And I'm showing you this notation now because in your calculus course, depending on your professor, they may use this notation as opposed to this one. I also don't mind on your homework. If you're used to this notation, go ahead. That's fine. I'll show you the right way to do it once, but I tend to stick with this inequality notation instead, okay? Now this one, to make it include the 2, you put a square bracket. Infinity is never included, so that would be a round bracket on that end. And here, this starts at negative infinity and ends at 2. So the square and round bracket indicate whether the number is included or not included. There are some other notations in older books where they always use a square bracket and they put it sometimes backwards or forwards, but that's older, outdated notation that we don't really use. So if you have seen it, it's still okay. A mathematician would know what it means, but it's not really used in anything that we would use here. Okay, so now what if I put some things together? So if I said x is less than negative 1 or x is greater than or equal to 2, how would we show that on a number line? So on our number line, we need both the number negative 1 and the number 2. We need both of those. So usually when there's 2 statements, we need to draw 2 number lines, one to see where it is, and then one final one that looks better and shows the actual answer. So what would we get here? So less than negative 1. So we're going to draw a new number line after. So if you draw it and then you need to erase something or anything like that, then you just do it. So less than negative 1 goes here, not including the negative 1, and this way. Greater than 2 is here, but including the 2, and bigger. Can you see that orange? Yeah. Okay, and there's nothing to change, but I'm going to show you what would happen if you did need to. So this is okay. They don't overlap. They're written as 2 equations. You can be in here or here, so that's okay. What if I changed the or to an and? Then what? So the difference is this is saying you have to be both here and here. Is there any answers? Is there any answers that are both less than negative 1 and bigger than 2 at the same time? No. So what would we say for this? No solution. If it asked you to draw a number line, there's really nothing to draw. Here's negative 1 and here's 2, and you don't put anything on it, no arrows or anything. And you would say there's no solution. Because you can't be in both parts at the same time. So you might want to jot that down. This is where people go very wrong on tests and things. They get the wrong thing drawn, okay? So what would you jot down? Well, you can't be in both sections at the same time, and there's the word and, which means they have to have an overlap. And there's no overlap, so there's no solution. Okay, there's lots of different cases, but what about this one? Greater than 1 and less than negative 2. So there has to be an overlap because of the word and. There has to have some overlap. So if we draw the number line, we have a negative 2 this time and a positive 1. So put the numbers on in the right order. And then you sort of jot down what it is. So greater than 1, not equal, so that's over here. And less than negative 2. Here, what do you think? So the word and is there, so we would say, nope, no solution. So what if I change this to be x is greater than 1 and x is greater than negative 2? Negative 2 and 1. So greater than 1, greater than 2, or negative 2. Okay? Now, is there an overlap? Is there a place where you can be in both of these at the same time? Yes. Where is it? So here, do you see there's both? When you draw greater than 2, or greater than negative 2, and bigger than 1, these numbers in here, like 2, 3, 4, all of these numbers work in both of these at the same time. That's the overlap. So our answer would be what? X is greater than 1. Not equal, because you can't equal 1 in this one. But here 2, 3, 4, 5 works, and here 2, 3, 4, 5 works as well. But the numbers in here don't work. Right? Because they're not greater than 1. So you have to look at the overlap, and our number line for that would just be you can put the -2 on there if you wanted to, but it really has nothing to do with the solution. All right, so sometimes one whole piece is not necessary to the solution. Really all we needed was that part. Now what if I put an or between those same two? So or means it doesn't have to overlap. It can work in one or the other. It doesn't matter which one. You can pick answers that work in either or. So how would we summarize this answer? Same number line. This is greater than -2 and greater than 1. Or means these work because they work in this one. These work. Does it work in that one? What about the number 1 itself? Does that work in this or this? Yes, it works in this one. It's greater than -2. So you only have to be in one or the other, and all of these numbers work in either one or the other. So our answer here would be greater than -2. And you could put the 1 in if you wanted to, but it really has nothing to do with the question. So, or you don't care about the overlap. It's just where all of the numbers are all together. So you don't need to sort of erase the number line. You could just color it all in, and whatever's colored is the answer. So you could just color it all in. This would all get colored for this one. This would all get colored for this one, which wasn't necessary because I already colored it all in. And so that's the answer. You don't need to look at the overlap when it's or. You just color it all in, and that's the answer. Where an and, you actually have to look at it and say, where is both happening? And then that would be the answer. All right, so here's 4. Leave some space if you're writing them all down. So we need a sample number line to sort of look at it, and then a space to write the final answer, and it might be that we don't need all of this to write the final answer. We might just need one part or the other. So for the first one, so our little sample number line, we've got a 0 and a 1. Make sure you get them in the right order. A lot of times people put them backwards, and you've got the wrong answer for sure. If you get confused which way the numbers go on a number line, think about a ruler. If you were to lay a ruler down on the page, 1, 2, 3 goes in that direction, so it goes the same way, and the part of the ruler you can't see would be the negative. So if you think of it that way, it should help. All right, greater than or equal to 1. Goes that way. Greater than 0. Do we need the overlap or just all of it? Or all of it. So it doesn't matter what happens, where is it all colored in, so it all goes this way. So the answer to this would be that x is greater than 0, not equal, and it goes in that way, and the 1 was not needed. Next one. And here's 0, here's 1. And means the overlap, so it's only where they're both colored, which is at the 1 and bigger. So here we'd say that x is greater than or equal to 1, colored in, and that would be your answer. What about the next one? It's weird. Greater than 1 or less than 1. What do you think? So everything, and it's or, so we don't need to look at that overlap, it's just wherever.
Everything's not equal 1.
Yeah, exactly. X is not equal to 1. And usually when we say it's not equal to something, we add x as an element of real numbers to say we want everything else. So the only part that doesn't work is 1, but every other number will work in that. And that's how your number line would look. Just a circle at 1. This one? We have a -1 and a 2, less than 2, greater than -1. And it's the word and, so we're looking for the overlap, which is between the two numbers is where they overlap. So on a number line, you'd show it that way. And when it's an in between, you write it in between. You don't write it as two separate ones with an and. You would put it in between. Now just this one, what if I had an or in here? I mean an and in here. What if I change that to an and? No solution. Why? Because you can't be bigger than 1 and less than 1 at the same time, and means the overlap where it's both at the same time. Okay, and one last one. Last one. Draw the number line. Greater than 1 or less than 2. So put your 1 and 2 in the right order. Greater than 1, less than 2. And we want or. So with or, you don't even need to look at you don't need to look at the overlap, you just look everywhere. So if it's less than 2, that's all of these numbers. And greater than 1 is all of these numbers. The 2 got colored in now. So that's sort of everything is just colored. So how would we answer that? Yeah, X is an element of real numbers. So it can have no solution, it could be all the solutions, it could be one solution missing, or it could be one direction or the other direction. Now, what we're going to do next class is solve inequality equations. So solving equations involving inequalities, and then putting absolute value and inequalities together.